Hi, my name is Cry Bachman and welcome to Shared Coordinates because after all these years, I still don't get it. So what is it about shared coordinates inside of Revit that makes them so hard to understand, and why is it that after all these years, frankly, people still don't get it? And can you truly master shared coordinates? I believe you can, and that's why I put together this presentation. But before we get started, you need to know that out of everything that I've learned in Revit over the years, that this has been the hardest concept to get. Now, if you look at my bio, you might be saying, what is a leader of digital innovation that works on smart buildings, computational designs, and AR? Why are they talking about shared coordinates? Well, it started many years ago. You see, I started in interior design, but in 2008, I relocated to the UK. I started with Gensler there, moved from a design role into becoming the BIM manager for the London office. And after that, moved on to Pollard Thomas Edwards, becoming the firm's BIM manager. As a BIM manager for both of these firms, I was responsible for setting up and coordinating some major projects. Any of the projects that were done in the UK were set up using the Ordnance Survey Grid, a real-world coordinate system that covered the whole of the United Kingdom. So doing it again and again, I had to get it right. But I found that the way I was setting up in Revit was really hard to understand, and I would move a point and it didn't react the way I thought it would. So I set about creating some exercise files that would allow me to understand and truly master shared coordinates. Fast forward a few years, and I returned to Canada and landed with a multidisciplinary practice called Dialogue. As you can imagine, when you're dealing with this many disciplines and this many models, you want to get it right so that everything is aligned and coordinated. So I've continued to teach my staff how to master this dark art. And that's what we're going to run through with you today. We're going to go through this theory of shared coordinates, learn how to set them up, how they get applied to a project that's in real world coordinates, and how to overcome the sticky situation that Revit has with a 20-mile limit. I also wanted to say that I'm going to be providing a link to the presentation, a handout, and a dataset or exercise files. These exercise files are the ones that I've developed to understand shared coordinates and really kind of see what's happening behind the scenes. So hopefully, if you download them and work with them yourself, you'll also understand them the same way. And I wanted to give a special thanks out to the guys at UK Map Center for supplying an example DWG file that we've included in the set. Now lastly, before I get started, I wanted to say that this presentation is based on my opinion. You see, with shared coordinates and a lot of other things inside of Revit, there's more than one way to do it. And this is going to be a quick overview. It's a very hard concept to get, and frankly, it's best actually learned by just setting up projects again and again until you get it right. But it's quite a difficult concept to get because it only really happens once per project. So if you're working in architecture, you might set it up, but it could be 2-3 years before you actually have to set it up again. That's one of the advantages that I had being a BIM manager in a firm. Now, we're going to start with the theory. So why do we use shared coordinates? Well, we might be setting things out by coordinates on a project. You see, projects that use robotic totaling stations for setting out the site, perhaps locating core drill locations, may require us to do some of that by coordinates rather than dimensions from a landmark. Those coordinates might be set out from a local benchmark, say the corner of a property line, but you might also be using real-world locations, such as the OS grid that I mentioned above. And as you will see, shared coordinates are essential for this. You also might not care about the coordinates, but you might have a project where you need to align a bunch of different models that were started with different origin points. Shared coordinates can help with this too. But lastly, I would say that you want to get it right because you want to avoid doing something like this. Now, I'm not saying that this project was caused by an error in shared coordinates, but I use it as an example of what could happen if you get it wrong. See, they built the cinema, and they built it 75 centimeters further north than it should have been, and once they discovered that it was wrong, they had to dismantle the structure and start again. The newly restructured structure was still a further 20 centimeters to the north and 30 centimeters to the west than it should have been. Moral of the story, you want to get this sort of thing right, because this is the sort of thing that could get your project in the headline if you don't end up getting the shared coordinates correct. So let's meet the players and the concepts that you'll need to know to work with shared coordinates and manipulate them inside of Revit. The first concept that you must understand is that Revit does have an origin point. Up until recently, most people didn't know, and that's because it was hidden most of the time. In fact, you used to have to use a DWG linked in origin to origin just to find the darn thing. But in Revit 2020, they now made it so that you can turn it on and off in the visibility settings under Site. It's important to understand that it exists because Revit was designed so that you model everything close to the origin point and avoid complex calculations with geometry too far from its origin. This was known as the 20-mile limit, but we'll talk about that in a bit. You will also note as we work through this example that your model never really moves relative to the origin point. That is, that they actually always stay in the same place. Since you can't move your model too far from the origin point, Revit was designed with a system that would allow you to leave it where it is and then tell it to behave as if it's somewhere else. That's the shared coordinate system. How do we control this mystery system? The next 2 points that we need to know are the project base point and the survey point. Now, a lot of people that I've worked with call these two origin points, and I want to make it clear that they are not. They are tools that we use for setting out the coordinates, but they are not the origin of the grid itself. Let me show you how. Project base point is the round one, and is used for creating a movable anchor that allows you to align multiple files together. It's basically an alignment point. And until recently, it was also a way of locating your project on the shared coordinates grid. But as of Revit 2020, that function has been removed almost entirely. Survey point is a triangular one and is your direct physical link to the shared coordinates grid. You can use it to push and pull the grid around your file. So let's see how these two files work. In this example, we have a typical setup of a file with two linked buildings. I have a site file separated from the buildings because as the project progresses, we may need to move the buildings around on the site, and it's a lot easier to do so if they're just linked in. Now, in this example, you might ask, but how do you work in the building files if they're at such odd angles? Well, you don't. You see, right now we're in this site file, and this has a project north. It's squared up with the property line so that when you print off the site plan in this orientation, it's aligned with the sheet. But if you were in building A, it would have a different project north so that you can draw the walls at 90 degrees to each other. And in building B, it would have another orientation altogether. So if all these projects have a different north, how do they sit together? Well, true north, of course, how they would in the real world. Now that we know how all the projects are aligned together in orientation, but how do they know their distance from each other? Well, their orientation is controlled by project north and true north, but their distance is controlled by the project or shared coordinate origin, and these are all tied together. You see, the shared coordinate grid is a grid that is imposed over top of the files so they know how they sit in relation to each other. And as you can see, that's the alignment to true north that all of them align to as well. Now, before we dive into Revit to see how this works, there's a few more ground rules you need to know. I'm going to fly through a lot of information, and if it doesn't sink in right away, don't worry. You can always come back to this. First of all, when you set up a project, you need to make sure that you choose a project north. You see, for each of your files, you have to make sure that it's oriented in the proper way that you want to work with it. As for how all the files align, that doesn't really matter, but you typically want to model in an orientation that makes sense when you print it out, or in 90 degrees to all the walls. Some people have actually started site files, and they've started them in true north, which, yes, you can do for that, because a site file could have a true north as a project north. But for most buildings, you don't want to start modeling in true north. You want to start modeling in project north. You might say, well, wait a second, inside of Revit, they have a rotate project north function. Why don't I just use that to kind of change it when I want? Well, you see, unlike the rotate true north function that we'll follow on later, the rotate project north actually moves geometry within inside the Revit file in relation to the Revit origin. It's one of the few functions that will actually change where your model sits compared to the origin point. There's one small problem. Some of the geometry and elements inside of Revit will obey this command, and some of them will not. So I've actually seen entire model files where a very large complex model had been created and it had been modeled at true north when we wanted to orient it to actually something that would fit more to the sheets, and we rotated it the project north. The model actually started to explode in the way of geometry with little bits of modeled in place components and massing going all over the place. So if you want to rotate your model afterwards to get it to work better because it was modeled at the wrong angle, I'd actually suggest using scope boxes for alignment and rotating those, and just forget about trying to affect your project north. Next, I will mention the Revit Origin. And although we will be focusing on shared coordinates that mostly ignore this point, it's important to understand where it is because the shared coordinates, first of all, don't affect the Revit Origin. And it is hidden in the background, but you can turn it on. But there are certain functions that do actually pay attention to this. For example, when you link two models origin to origin, that's the origin point that it's using. As well, if you've ever exported DWGs and you've checked the box that says you want to use project internal for the coordinate system for exports, that's actually going to use the Revit internal point. And the other reason that you want to know about it is because there are some functions, such as importing topography through a CSV file, that completely ignore shared coordinates and rely more on the Revit origin point. So it's actually quite important to have a sense of where it is and put it in a logical place in relation to your model so that you can come back and use it again and again. Here's a little bit more information about the shared coordinate system. As I mentioned, it's a bit of a hard concept to get, but because of the way everything's modeled around Revit Origin, the idea of it is that your project actually stays in one place and the world moves around it. This means for switching between things like Project North and True North, it's actually a graphic change that's happening. And it can deal with both the X and the Y, the northerns and eastings, but it can also deal with your elevation values. So you don't actually have to model things at the proper level above sea level, for example, but you can actually just tell the model to behave as if it's at a certain height. I do want to say that it is similar to the UCS function that some of you may have used inside of CAD, but it's actually more powerful. So not to sort of overlook it as something that's a simple, oh, I know how to use that. It takes a while to get used to. Now let's look at how it behaves between files. So sometimes the system is called project coordinates or shared coordinates, but it's referred to as shared coordinates because it can actually work between multiple files, and hence the shared part of it. The other thing is that this is a system that actually can influence the linked models. So you can actually change a coordinate system and then push that information from one file into another. It is one of the few functions that will actually reach into other files, which is important to understand, especially when you're working with other consultants where you're linking in models that are not your property. The other really neat thing about shared coordinates that took me a while to figure out is that you can actually link a single model into a Revit site file multiple instances. So for example, if you have a single housing type that you actually want to repeat down a street, you can actually do this and you can locate each one in its separate lot. Although it sounds complex and it's something that you have to get right and never touch again, it is actually flexible. So you can actually update as you go. And that's one of the other reasons why to learn how to manipulate it around. Now, I learned shared coordinates when I dealt with the UK's OS grid. As I mentioned, Revit is great for keeping the models next to the origin and then telling them to behave like it's 300 miles away from its OS grid origin. But what about the 20-mile limit that I mentioned before? Well, if you draw a circle 10 miles out from your Revit origin, you create a 20-mile diameter. And that limit, Revit does not like to exceed. This means that if you're an urban planner out there trying to do a master plan of a city, Revit is not the right tool for you. So what do we do then when we want to work with stuff like the OS grid and we want to work with DWG files that have an origin that's beyond the 20-mile limit? Well, we localize it. Now, wait a second. I've been told again and again, surveys, files you get from other people, you can't relocate these. Well, I'm going to show you guys that you can if it's recordable, repeatable, and verifiable. That is, that you're in control of the process so that you can show people, yes, you can do it, and yes, I've put it into the right location. And we do this by referencing it into an empty DWG file, relocating it down, recording which distance we moved it, and binding it in. That localized file, then Revit will not have any issues with. I'm going to show you guys this on screen, and it'll make a bit more sense. All right, so we're ready. Let's get into Revit and see how all this works live on a model. Now, as I mentioned, I've included a dataset or exercise files for you to download and work through on your own. We may not touch on each of these files individually, and we may not go into all the examples. I've included them because these are all the different files that I've developed in order to teach my staff how to work with shared coordinates. Now we're going to start with the concept file, and specifically the second file, which is the example of a concept with site file. This is a pre-established file where I've set it up like a site file, showing you the property line with two linked models, and you can see the project base point, the survey point, and the Revit Origin. And you'll also notice that I've revealed the shared coordinates origin. Now, I did this by linking in basically a large file with a grid and setting it to be active on shared coordinates. And because it's always located close to the 0 by 0, it allows you to manipulate the shared coordinates around and see what happens when you move different points. Does the survey point affect it when it's unclipped? No. But when I clip it, you'll actually be able to see physically how the shared coordinate system moves about. Now, I wouldn't recommend actually importing the shared coordinate origin grid into a real-world project because most likely it's actually going to be located hundreds of miles away if you're working with real-world coordinates. But in this little exercise file, what this will allow you to do is manipulate everything around and actually see how it's affected. Now, you might be saying, but wait a second, how did you get it all set up in this? And that's what we're going to be touching on next. So the next file that I'm going to touch on is going to be in the second folder. We're going to use these files, starting with the empty project file. We're going to take a look at these and we're going to set up this example in the background. So starting with the empty project file, this is what you would actually see inside of Revit if you just start a blank metric template using the Revit default ones. The first thing you'll notice is that there is nothing visible. Now, you could start drawing geometry in here, but it's important to understand that there are elements that are actually in view here, and that if we turn on our visibility settings and go under Site, we're going to turn on three different components: the Revit internal, the project base point, and the survey point. Once I turn these on, you'll actually be able to see that there is something in the space. Now, just for reference, I'm also going to just take a second to draw a few simple walls so that you can see how they sit in relation to everything else around it. Also, these points are a little bit hard to grab because they're sitting on top of each other. The Revit internal origin you cannot actually select, but the project base point and the survey point sometimes get a little bit confusing. If you see me select through stuff, it's because I'm hitting tab as I move over top. So my selection in the bottom left, you'll see switches from survey point to project base point. The main thing that I want to do here is select my project base point, and the first thing I want to do is just simply move it out of the way. Now, you'll see that it moves off to the side. And I'm now going to go back and grab my project survey point. If I move it off to the side as well, the problem with this is that I can't actually see what's going on around it. And this was part of the difficulty that I had with learning shared coordinates, is that no matter what I did with the geometry here, couldn't quite understand, well, why are these points, what are these points actually moving around? And so that was where I said, I really need to actually be able to sort of reveal behind the curtain and see what is actually happening with the shared coordinate system. Now, it's a little bit difficult when you're dealing with just, 4 walls on a page. So let's try setting up that example before where we have a property line and 2 buildings linked into a model. So the next file that we're going to start with is called example of a site. Now, this file, as I mentioned, I've already established the shared coordinates inside here. So what I did was I linked in a separate file that had this grid in it. You can see, if I zoom out, all it is just simply a grid that I drew inside another file. But I wanted to do this because starting off inside of Revit, I always start my projects with, for example, in the past, I typically would have had my property line, and then I would have had my project base point and survey point and my Revit origin all lined, just like you saw in that other file how you started. I also typically drew in some reference planes because the Revit origin wasn't always turned on, but it was always important to have a sense of where it is so that I could start my file in a logical place. As I said, it's important to understand where that Revit origin is because it is going to become important later on in different functions as we work through the file. Now you can't quite see it, but I do have my project base point and my survey point underneath here. Because I have a linked file, the grade ones are kind of appearing on top of that. And it also, I'm highlighting my property line. But if I tab through, you'll see that I can select my project base point, and I'm going to move it off to the side. And then I'm going to go back and tab select my survey point, and I'm also going to move it off to the side. And I'll move it a little bit further. Now what you'll see here is that I've actually relocated the shared coordinates origin, and that's because my survey point currently is clipped. But what I want to show you quickly is that a lot of people will say, well, yeah, that's because the survey point is the shared coordinates origin. But if I actually unclip this here and move it off to the side and say place it on this grid line over here, well, now if I clip it and I move it around, you will see that it's affecting the shared coordinates origin down here, but it's not actually at the origin point. So although it could be at the origin point, it isn't an origin point itself. It's just simply a tool that allows you to move where this origin point is actually located. Similarly, if you're working in Revit versions before 2020, the project base point, when clipped, could actually move the project around on top of the grid system. So effectively, it was doing the opposite of the survey point. The survey point moved the grid under the model, and the project base point moved the model on top of the shared coordinates grid, effectively doing the same thing, which is one of the reasons why I think Autodesk removed the clipping from it. So now that we have an understanding that the shared coordinates origin is actually located someplace else, okay, so let's start taking a look at how we can set up this file. We have a property line, and I want to sort of do this similar to that other example. I want to have a local setting out point of my origin point down here. So if I said, okay, I want to take my shared coordinates origin and I want to relocate it, by moving the clipped survey point down, you can see that I can actually relocate the grid off to the side here. Now, you saw that I actually had an orientation up in a different angle. So if I know that my site is actually sitting at a particular angle to true north, I can rotate that. And in this case, I'm going to show you that you can also type it directly into the angle to true north inside the project base point. Now wait a second, didn't we say that this thing doesn't affect the grid? Ah, yes. They took out the clip so that it doesn't move the northerns and eastings. However, the angle to true north actually still affects the orientation on the grid. This is the one function that the project base point still does actually affect when it comes to shared coordinates. So it's important to understand that changing that will change your project's setting out. Now you might say, okay, I'm doing this a little bit haphazardly. I'm moving things around and shuffling them left and right. Can we do this in a more controlled process? In the next example, I'm going to show you guys how to set this up using actual DWGs and real world coordinates. And I'm going to do it in a very controlled process. But the point of these exercise files is actually to be a little bit more loosey-goosey, allow you to sort of sit here and say, well, let's just roughly type in some numbers and shuffle things around and really get a sense for kind of more playing with the environment. This is a bit of a sandbox, so have a bit of fun and experiment with it. Try to use the different functions. Now, you'll notice that I, for example, rotated the true north by typing the number into the project base point, but there's also a few other functions that I want to show you. Within Revit, under project location, there's also a few different tools here for specifying coordinates at points, as well as rotating true north here. So it's important to understand that, as I mentioned, there's more than one way to do it inside of Revit. So the method that I'm going to show you guys for setting up a real world project and for experimenting within the sandbox here are just one way of doing it, and that you may find a better way that you prefer. I used to, for example, like to relocate my projects using the project base point, but now that they've removed that clip function, I can't actually do it using the project base point. Let's continue on with this example before we get into the meat of it, which is the real world example. I've now got my site file. I know that my orientation is slightly off to the side. You'll also notice that I've rotated my true north. So that means that if I actually switch this over to true north, I can now see it in a true north orientation. Next, I want to bring in a couple of files. So also located within that folder are a couple of other Revit files. So I want you to go back to the Revit Origin project folder, and I want you to look for Building A and Building B. We're going to take that address across, and I'm going to link them in here. Now, I have a few different options for bringing these files in. These two files have never been linked into each other before. I can bring it in center to center, which is just kind of an arbitrary placement. If I bring it in origin to origin, it's going to align the two Revit internal origin points. And I could try by shared coordinates, but because these files have never talked before, they won't actually know which shared coordinates to align. And lastly, project base point to project base point, which I'll show you in a moment, can actually be quite handy. I'm going to start with the Revit internal origin to origin, just to show you how it works. So you can see that I've brought in the file, and the Revit internal origin was located in the bottom corner here of Building A. It was also the same location within my site file, so it aligned the two. But you'd say, well, that's not really where I want it in my project. In this case, because it's a site file, we're actually going to move this entire building off to the side, and then we're going to sort of rotate it on site so that we can do a different orientation. So, for example, I want it aligned with this property line. So I'm going to rotate it at an angle like so. I'm going to move that a little bit more over, and there. Now I'm going to bring in my second file. Now my second file, I might say, well, I actually want it in a specific spot. So what it allows you to do within Revit is to take a project base point and position it. This is a newer function that only appeared a couple of years ago in the newer versions of Revit. And that is that if the two projects don't share the same origin, it's hard to actually bring them in alignment. So what they did was they decided to make the project base point the alignment points. And this is again where I say it's not really an origin, but they're kind of using it as a substitute for. So I would sort of call it an alignment point. So in this case, I'm going to go back in and I'm going to link building B. And in this case, I'm going to say, I'm going to bring it in by project base point to project base point. And you'll see what it's going to do is it's going to line up the two files, project base point to project base point. So the two base points are located on top of each other. This means that if you're working with a file, for example, where you know that they were created with different origin points, but you know the grid lines, and you know those 2 points have to align, then you can easily drop them directly on top of each other, as opposed to afterwards having to shuffle the models around. Now, in this case, I also want to adjust this one slightly, so I'm going to rotate it, and I'm going to position the rotate function here, and perhaps I know that it's got an orientation that actually aligns with true north. Like I said, this is a bit of a sandbox, and we'll see another example where I want to do this a bit more precise. Now, these two files right now are just linked in. And if I take my coordinate points and start moving them around, you'll notice that it moves the grid, but the property line and the two linked models all stay in the same place. And that's because these two models are just linked in by coordinates, but they're not linked in by shared coordinates. So they're just sitting relative to where the Revit origin is right now. So what I want to do is I want to actually establish shared coordinates. I do that, in this case, by picking the model and going under the properties, and you'll notice that it says not shared. This means that it does not have any shared coordinates active. It may be linked up at some point, depending on the models and the way they've been done. In this case, there has not been a relationship established, but they perform a bit of a handshake the first time. If you click on it and it says publish or acquire in your two options, it means the two files have never actually talked before. So in this case, I'm going to say publish. Now note that this is going to modify the linked models. So as I mentioned, if you're working with an outside consultant, you may not want to do this because this will actually affect their file that you're linking in. In this case, because this is just an exercise files, I'm going to say yes. Similarly, I'm going to go over to my second file and I'm going to do the same thing. Both files now have shared coordinates active. However, it hasn't actually been saved back. And that is that until I hit the save button, now it prompts me to save the position back into these other files. Again, as I mentioned, you have to be cautious with this because this will actually push information back into the other files. Something else to note, you also cannot have other people working in central files that you're linking into this file. So if you're working in a Revit work sharing environment, you cannot push this information back into the other files when someone else is currently working in it. So as a BIM manager, get everyone out of the files if you're going to mess around with shared coordinates. So I'm going to save this back for building A and the same for building B. So now we can see that both files are linked in by shared coordinates, and it shows this because they both say internal. Now, if I grab my survey point and I begin to move it around, you will know that they stay stationary relative to the shared coordinates origin point and not the Revit internal origin. This means that if I update my shared coordinates at any point, they stay in relationship to this and not the Revit internal. That also means you have to be very careful about updating it, because if you have multiple models linked in and you have, for example, a structural model and an architectural model, if one of them isn't linked in by shared coordinates and you update the coordinate system, you could end up in a scenario where the two don't actually align anymore. So as I mentioned, this little sandbox is a great little place to play around, be able to see how the different coordinate systems work. You can try out the different ways of manipulating it at the top, the different ways that you can position models multiple times and move them around. It's really your place to get to know shared coordinates. But ultimately, one of the questions that I get asked again and again is, how do I do this for a real project though? I don't want to play in a sandbox. I want to actually get my project set up right. So the next example that we're going to be looking at is one that uses real world scenarios. All right, so here we are in CAD, and we're going to start out by taking a look at the real world OS sample. This is a real world example based out of Wales in the UK. And as you can see, if I type in ID and pick a grid line intersection, so keeping in mind that this is in meters, that's 270 kilometers by 345 kilometers away from the origin point. I want to be able to locate this down closer to the origin point. Now, as I mentioned, you want to do this in a recordable, verifiable, and repeatable process. So one of the first things I need to do is kind of pick out, where do I want a local setting out point from? Now, a lot of people might pick something to do with their site. They might say, oh, I want to pick this corner of a property line. There's one problem with it, and that is that if you actually look down here, you'll notice that it starts to get into decimal points, and it starts to get into kind of arbitrary numbers that, 270, 208.3. It's not really a round number, and it's not really something that I'm a bit more comfortable with. Whereas if I pick one of my grid line points, you can see that it comes in with nice whole round numbers, and it's easily identifiable both in this plan, or if, let's say, I was given a survey from a local surveyor where they've done some work to record the topography, I can find that point again as long as they were both based off of the OS grid. So in this case, I want to be able to identify that. Now, in order to identify that point, I'm going to insert a block. In this case, I'm just going to use my CAD origin block. And in this case, I want to be able to specify the origin or the insertion point, and I'm going to leave the scale at 1 because it's millimeters, it's going to scale it up. I'm going to go down and find the intersection of my two grid lines, and that is now going to be my marker. Now, the fact that I marked this in real world means that if I get another survey point, or a survey file, for example, I can take this point and I can copy and paste it to the original coordinates in the new file, and it'll drop in the same spot. That is that right now, it's in the real world. So I'm going to start by saving my file right now so that I have a copy of that little marker. The rest of this, I don't want to actually affect this original file because I want to keep it and retain it in real world coordinates, and you'll see why when I come back to it in a few minutes. But what I do want to do, as I mentioned in my other slides, is I want to relocate it by binding it into a blank file. So I'm going to jump over to an empty file that I've also included in the folder, and we're going to continue from here. So the first thing I need to do is get my XREF in. So I'm going to insert my sample one that I've just saved. Now, when it comes to the insertion, I have to note here that this original file is in meters and I'm now working in millimeters. So it's going to factor it up by 1,000. The rest of it, the scale, I'm going to leave as the same, and the insertion point, I'm going to leave at the origin point. Now when I do zoom extents, you'll see that it's still located out in real world coordinates. You can see my marker here. If I type in ID and pick that point, it's still going to give it to me, but it's now going to give it to me in millimeters. So this point, I want to actually remember because I'm going to have to come back to these specific points shortly. But now what I want to do is I want to grab this overall file and take it down to my origin point. Now you might be asking, why do I do this inside another file? Well, part of this reason is because I've run into problems where I've tried to take in a file like the original, grab everything, and move it down to a different point. But if any of the particular lines in here are locked or frozen, you'll end up missing certain geometry. So sometimes it's a little bit cleaner just to go into a blank file, insert it as an XREF, and then relocate it. Now the other piece that I want to do before I go any further is I want to make sure that everything came in correctly. So it's also important to just quickly measure off something and make sure that, okay, yeah, in this case, I can see down here it is measuring 10 meters, or in this case, 10,000 millimeters. And I know that it's scaled in properly. This is very important because although you can insert things and they can start to look like they're in real world coordinates and at the right spot, if the scale hasn't been right, you'll suddenly find yourself kind of going in circles trying to figure out what went wrong. So next I want to take this file, and as I said, I want to locate it down by the 0 by 0 to localize it. So I'm going to grab my XREF and I'm going to move it based off of this point here, this intersection, and I want to move that down to 0 by 0. So I'm going to put in hashtag 0, 0. The hashtag is important because you need to tell it it's an absolute. Now, when I do my zoom extents, you will see that it's located down at the 0 by 0. Lastly, although I could maintain this as an XREF, it's still going to potentially give me issues when it comes to the 20-mile limit. So right now, what I'm actually going to do is save this as a new file, and I'm going to bind it in. So again, I don't want to affect my original file, so I'm going to do a save as, and what I usually like to do is just use the word local at the end to tell me that it's a local setting out. Once that file is saved, I'm going to take my XREF, I'm going to bind it in, and now it comes in as a block. There's only one additional problem, which is that this block now still has an origin point based down in real world coordinates hundreds of kilometers away. Therefore, what I actually need to do is explode it. So now I've got the geometry back to something that's manageable, and I've got my local setting out point. So let's jump over into Revit and you'll see what I do next with the file. Back in Revit, we're going to start with a blank empty Revit file. This is number 4 here. And we're going to be linking in the local file that I just created separately. Now when I go to link it in, there's a few options I can change here. First of all, I'm not going to select the current view only because I actually want this into the sort of model space or the actual environment and not just the current view. I'm going to set my colors as black and white, but that's a personal preference that anyone can change. And down here, I'm going to set my units as millimeters just to make sure that it's coming in correctly. As well, I'm going to change this to unchecked because if I'm dealing with a survey, I may actually want my line slightly off axis. With the OS grid maps, not so much, but I'm going to leave it unchecked anyways. Over here, I'm going to check origin to origin because, as you'll see, I want to bring the two aligned. And lastly, I'm going to uncheck the orient to view because I have had some drawings rotate themselves afterwards when I reopen the file when I've had this option checked. Now, as you can see, it's dropped it in right in the middle, right on top of my Revit Origin point where I had my reference planes. And you can see it aligns with the 0 by 0. So now if I zoom extents, you can see I've got my model in place. Now, before I get started, one of the first things I also like to do is just do a double check that everything's come in correctly. So I want to just do a quick measurement on my scale here. And as you can see, it says 10,000. That is 10 meters because the project is actually in millimeters, even though this drawing was in meters. Now, before I get setting up my coordinates, I actually don't want to draw my site with this orientation. You see, I want to use a different project north. Therefore, I'm going to actually have to rotate this DWG in my model space inside of Revit. So what I'm going to do is I want to pick this particular line here at the top to have it orient. So what I'm going to do here is I'm just going to draw a quick reference plane along this edge. And then I'm going to take that and move it down to my origin. Now, because I brought the file in origin to origin, it's actually pinned in place, so it's not going to let me rotate it until I unpin it. I'm going to unpin it, and I'm going to pick it along with my reference plane, and I'm going to rotate the two. I want to have it rotate around this base point because I want to have the two stay aligned. So I'm just going to move that down by hitting the space bar on the rotate function. And then I'm going to pick my reference plane and snap it down to one of the grid lines. You can see now, as I look at this line, my plan is oriented properly and it's in a new orientation of Project North. So now that we've rotated Project North and we've established that correctly, the problem here is that Revit doesn't understand which way is actually up. So we're going to have to rotate our true north. So with that again, I'm going to come into my base point here that I'm going to focus everything around. I'm going to go up to the top here to my additional tools. And I'm going to rotate true north. Now, it's going to give me a message saying that it can't actually rotate. And that's because over here, my drawing is still set to Project North. So, quick switch. Go back to the tool. Now this one's a little bit tricky because you sometimes get it backwards, but what you're looking to do is pick your true north and tell it this direction is up. And because we've got the linked in DWG, I can actually orient that straight up, and now it knows this is my true north orientation. So you can see that I've got my true north orientation, or if I switch back to my project north, that's my project north. Next, I want to actually set about telling it where the coordinates are, where it is in the actual real world. So to do that, I used to actually go back down to my project base point and type the coordinates into it. But since Autodesk has now changed things up, although I can turn on my base point, it's actually not my project base point that I'm going to use to set the coordinates. So I'm going to turn them on because it is important to actually be able to see these. So under my site settings, I'm going to turn on my Revit internal origin, my project base point, and my survey point. So in the past, I would have typed the values into my project base point, but now I have to use a different method. You'd sort of say, okay, well, what values do we actually pop into this? Well, this is where we have to go back to CAD to double check what our values are from there. And in this case, I want to make sure that I'm going back to my original file, the real world OS sample. You see, I need the actual true value of these, not the relocated localized ones. So again, going back to my point here, I can type in ID and pick this intersection of the two grid lines here. What you'll see is you get the X and the Y values here. It's important to understand that this is in meters, so we actually have to add on 3 additional zeros at the end to make sure that we get the conversion correctly. So I'm going to copy these values over and bring them into Revit. So the first value I took was the X. what I can do here is I can specify coordinates at point, and by picking this vertical line on my grid, I can tell it that in the east-west or along the x-axis, I need these values. Again, remembering these are meters, so I have to add 1, 2, 3 additional zeros. And the way it goes. Next, I need to do the same thing for the y values. Take the value from CAD, and in this case, in Revit, I'm going to specify the coordinates, points, and I choose the horizontal line. And again, add 3 zeros. You might look at this and go, wait a second, something has changed here. Where is our survey point? Well, if I do a zoom extents, you'll see now it's sitting way off there. Now, the funny thing about this is, you might say, wait a second, isn't that beyond the 20-mile limit? Yes, it is. However, Revit doesn't seem to care about its survey points going beyond 20 miles. Now, in this case, I want that survey point to sit somewhere a little bit closer, because anytime I have it positioned out here and I do a zoom extents and it's turned on, well, I'm going to get this result, which isn't very productive. So I'm going to unclip this, and I'm actually now going to move it. And in this case, I'm just going to grab it and drag it back up until I snap onto something local. If I do zoom extents again, you can now see, I almost got it back to its original base point. I'm going to leave it unclipped right now because I don't want it to affect the shared coordinates moving, but effectively, we now have our project set up in shared coordinates. And I can check this because what I can do here is I can start to do a bit of a comparison against the actual site file. So I'm going to switch it back to true north just so that you can see the orientation properly. And what I'm going to do is I'm going to pop in a spot coordinate. So under annotate spot coordinates, I can drop something in, and you can see that if I pop it along this line, you can see that the north value is reading correctly the same as the value as the line here. If I do the same on this line here, pop it down, you can see that it's reading the same 270, 300, with a few zeros added on the end because it's in millimeters. What you want to do is you want to do this a few times around your file. If all the values read correctly the same as your file around the outside, you've got it correct. Now, if you don't have a file like that, where you've got the values on the outside on grid lines, you can also go back into CAD, type in ID, and pick a particular point, and it's going to give you the X and the Y coordinates, just as you saw I did to double check this location of the grid lines. Then, if you compare that to a spot coordinate off the same point, you'll know whether or not you have it correct. A lot of people ask me about, well, where should the project base point sit? Where should the survey point sit? You know, did I get those positioned correctly? Well, in truth, it doesn't really matter where they sit as long as the shared coordinates are actually reading correctly. Those positions will relate to other things such as linking models in project base point to project base point, and you keeping tabs on where your survey point is and you're setting out for your project. But they don't actually, their specific position and where they are, as I said, is not where the origin point for the system lies. Therefore, it doesn't matter if they actually sit on this grid line, or if I move them off to the side, or if I position them on within my building. It's more about the fact that, is your project reading the correct location? Is it actually reading the correct X and Y values, the same as the CAD file? If it is, then you've set up your shared coordinates correctly. So now let's get a couple more files linked in here, and we'll see how we set up them in relation to each other. So now that we've got our site established with shared coordinates or project internal coordinates set up, effectively getting it to behave like it's in a real world situation, we're now going to get building A and building B linked in. So I'm going to start with this file, and I'm going to move on to this second file. I'm going to leave the structure for building A to show you another way that we're going to set up the shared coordinates in a minute. So let's start by linking these two files into our main site file. Now we're simply going to go up to Link Revit in the Insert tab at the top. Remember, I want building A in this case. Now, I have a few different options for linking it in. Again, I can do center to center, but it's just going to kind of arbitrarily place it. Origin to origin, which is going to bring the two fairly close together. Another good option. I can't use shared coordinates because these two haven't officially done their handshake yet. And of course, I've also got my project base point to project base point, which I showed you in a previous example of how to link the two files together. So in this case, I usually start off with origin to origin just because it does happen to bring them in fairly close together. Now you'll notice that it comes in at a funny angle. That's of course because again, I'm working in true north. So I'm going to bring in the file here. Shuffle it around on my site till I get it into a place. Now, in this case, it's aligned with Project North, but perhaps I'm actually setting out my building at a slight 5-degree angle on the site, which is where it actually is going to be built in real life. Next, I'm going to bring in the second building, and then I'm going to establish the coordinates to show you how it all hooks up. Again, bringing it in. In this case, I might just pick by project base point to project base point. You can see how those two link up, which in this case brought in the same location because I haven't moved my project base point from the origin. But again, if you had a scenario where you had a project base point, you knew you wanted to bring it in up here, for example, to a specific location, you could easily do that. I'm going to rotate my model. In this case, press the space bar to align it. The model, then with this wall, just so that I can position it parallel to that wall there. Now, I have my building A and building B. Now to establish the actual shared coordinates. So the way this functions is the files do almost a bit of a handshake, and that's the reason why you can't bring in two files by shared coordinates until they've officially done this. The easiest way that I find to do this, and again, there's lots of different ways to do it, is to pick up the model, and then you'll notice at the top here it says shared site, and it will say not shared. So I simply click on that, and then I can see that I haven't established shared coordinates because I'm getting an option that says publish or acquire. Now in this case, I want to take my file and I want to tell building A that it's sitting in the right coordinates in the real world based off of the site file that it's linked into. Therefore, I want to push this information from the site file into my linked file. Hence, I'm going to go with a publish. We'll get to acquire in a minute. Now, a lot of people will hit reconcile at this point, but there's one other change that I want to make, which is that building A has a site that's simply called internal. In fact, all the shared coordinate sites are called internal to start because the project base point and the survey point are aligned with the Revit internal origin. But one of the good ways to kind of signify that, hey, this project has shared coordinates set up is to actually change this name, because otherwise if you don't, all of your descriptions up here in the properties will just simply say internal. And it's not really a good sign to say, hey, I've set up shared coordinates and you should be paying attention to them. So I'm going to change this setting here. I'm going to rename it, and I'm going to call it Building A on site. Now, a lot of people will change this to be the name of the project or a bit more of a description of lot A, for example, on the project site or something like that. But it's important that as long as it's something that's recognizable by the project team, it'll be something that stands out as opposed to just internal, which is the default. Once I'm done with that, I simply hit reconcile, and it's just about done. There's one more step to go, but first I'm going to jump over to building B and make sure that we do the same thing here. So simply the same steps. I'm going to pick it. I'm going to publish mine. I'm going to change my name. And again, in this case, building B on site. Okay, I hit done. Okay, reconcile. Now at this point, the shared coordinates actually haven't been pushed back into the other files. What you actually have to do is press save for your main file. At this point, it's going to prompt you to say, do you want to save this information back into the other files. So again, I can hit save, and for building B, same thing, save that information. So this is again remembering that this is one of the pieces inside of Revit that can actually affect a linked-in consultant's model. So you do have to be cautious when you use this, because if you push that information into a file that you've been sent remotely, for example, the next time they send you the file, it's not going to have that information embedded into it. So what you actually have to do is typically send them your file and they'll acquire from it. We'll show you an example of that now. Now, before we open up the other models, I need you to save and close these files because you can't have them open if you want to link them into other Revit models. So the next file I want you to open is the Revit structure file that I referred to earlier for building A. As you can see, it's set up and it doesn't have any of the other files linked into it. So what I'm going to do right now, I'm going to go up to here and I'm going to link in my building A. I'm not going to link in my site file because I want to acquire the coordinates off of building A's architectural model. Now, in this case, I'm going to try to position this origin to origin and see what happens. Oh, you can see somebody else started the other file, but they started it with the origin in a different location. Now, we already have the grid lines established in this file, so this is going to be a quick fix. I simply grab my model, pick it from the grid lines, move it down so it aligns with mine. That was kind of an easy, quick fix. Now I've got the two models established here, but as you can see, when I look at my shared site, it's not actually established yet. The structural file has not done a handshake with either the site file or the architectural file, so it doesn't know anything about these shared coordinates. But I can easily fix that by picking my architectural file, clicking on my shared site. In this case, I want to acquire. So when you use the acquire command, it's not actually pushing the information into the other file, it's simply pulling that information across. Therefore, it doesn't actually affect the linked file. This one's actually an easier to use method when you're dealing with outside consultants' files. You'll notice that it also says it shows the site, and yes, this is the site that I want it to link in by. You saw how I established it on the other file, and again, if it said internal, I wouldn't quite know whether or not they set it up correctly. But this tells me building A on site, or if it had the project name, I'd kind of have a bit more of an idea of, yes, they've done this right. So at this point, I simply say reconcile, and then I'm going to save my file. Now at this point, we have we have the architectural file for building A, and we have the structural file for building A, but we don't have the site file in here. But because building A, architectural, was already inside the site file, and they've done a handshake, and now these structural and architectural models have done a handshake, we can now jump back to the site file and link the structural file directly back into it. So now I'm back in my site file, and I've closed out of all the other files, because again, to link them in, I have to have them closed. So again, we've got our overall site, and we have our building A. Well, now you'll notice that when I go in to insert here, and I pick my building A structural, well, I can actually go in here and select by shared coordinates. And because building A architectural and the site file did a bit of a handshake, and then building A architectural and the structural did a handshake, this file will now know exactly where it needs to drop into place. You can see the structure dropped in knowing where it sits in real-world coordinates. So at this point, especially if you're new to shared coordinates, you might still have more questions about how do you link one model into multiple locations, when is it best to use acquire versus publish, and how do we update these coordinates as the project progresses. Unfortunately, as I said, it's a big concept to get your head around, and there is only so much that we can cover in an hour. What I hope you have gained from this session is a basic understanding of how the same concepts, shared coordinates, apply within this conceptual sandbox file that we started out with to this real-world example once we overcame the 20-mile limit. But honestly, the only way you'll truly understand it is to get your hands on the exercise files included with this class, or on your own project files, Practice setting up projects again and again until you have mastered this dark art. Thank you.